This is 3-1's homework in your algebra book. We're looking at linear equations, so equations that form lines, and we're specifically looking at graphing them here and representing those linear equations visually on a graph. So we are starting with number 1, and we're going to be looking at everything we see here with a table and a graph, and then answering some questions based on that. So a flooded stream is 18 inches above its normal level. The water level now is dropping. Now we need to make sure we notice that dropping, so we're going to be subtracting 3 inches per hour. Now this is where it starts to get a little confusing if you're not used to the language of algebra. It says its height y, so basically that's just telling you that the height is going to be represented by y in our equation. We use y and x a lot. So the height is y, and that represents inches above normal after x hours. So x in our equation is the number of hours given by this equation. So y equals 18 minus 3x. So y is the height. So the height is equal to 18 minus 3 times the number of hours. So you do 3 times the number of hours, you subtract it from 18 because it's going down by 3 per hour, and that number is going to equal the height. So we have a table. Part A is to complete that table. So we have x, which is time, and we have height, which is y, and we're going to go for 0, 1, 2, 3, and 4, and these are hours here. So how many hours have passed? So when we see x or time equals 0, that means no time has passed. That's what we started with. So they're telling you started with 18 inches, and they gave that to you. And then it's going down by 3 inches, dropping 3 inches per hour. So even if you didn't use the equation, you're just every 1 hour dropping it 3. So 18 goes down to 15, goes down to 12, goes down to 9, goes down to 6. But you also could have derived that from the formula. If you took 1 hour and you plugged it in, y equals 18 minus 3 times 1. 3 times 1 is 3, and 18 minus 3 gets you the 15. And then you could have plugged in the 2. You would have got 6. 18 minus 6 is 12. And so this equation will produce these numbers. But since it is just dropping by 3, it's also just as easy to just subtract 3 every single time. But let's say we wanted to know after a much bigger number, instead of having to count all the way down by 3s, you could just plug it in. So after how many hours will the stream be 12 inches above normal? So letter B, you just have to find it right here. After how many hours, that's your x, will the height be 12 inches above normal? That's your y. So what is x when y is 12? And the answer is 2. Now specifically, that's 2 hours is what we're talking about. Letter C, how high above normal will the stream be after 3 hours? So hours is our time. So when x is 3, what is y? What is the height? And so it's 9. Now 9 what? 9 inches above normal. And letter D, after how many hours will the stream be back to its normal level? So remember this number, 18, that's above its normal level. Then it's 12 inches above its normal level after 2. So normal level would be represented by 0. They basically want to know when is this 0. So a couple options. You could try and figure it out using the formula, but you could also just keep counting since we're already close down here to 0. If I went to 5 hours, it would drop another 3 and be at 3. And if I went to 6 hours, it would drop another 3 and be 0. And 0, when it's 0 inches above normal, that means it is normal. And so they're asking you how many hours. That's your x value. And so it's 6 hours. All right, going over to number 3. So number 3, we're looking at a train. It has an engine, so that front part is 60 feet long, and it's going to pull the rest, and all the cars are 40 feet long. Now, there's a distance between the cars. They're not actually going to be, butted right up against each other and touching. There's a little bit of a distance of 2.5 feet between every single car. So if I asked you, and they will, eventually, what's the length of the train with one car, you can't just add the length of the engine and the length of a car because there's also a little bit of space between them. So from front to back, it's not just the length of the car is added together. You have to factor in the space between them, which is 2.5. So when we get to letter A, The total length of the train with one car is going to be the 60 up front. I want to show you this visually. So that's the engine. You're also going to have the 40 of the car, but there's this space between them. The engine's pulling this car, but it's 2.5 between them. So the total distance from front to back is not just 60 plus 40, but you also need the 2.5. So 60 and 40 is 100, and if I add in the 2.5, that comes to 102.5 feet. So letter B, what about if there's two cars? So now I'm adding another car on here that's 40. But again, that 40 is not touching this 40. There's space between, they're hooked together, and there's 2.5 between them. So from here to here, we already calculated that distance is 102.5. So what are we actually adding to that now? We're adding the 40, and we're adding another 2.5. So this distance is 42.5 that we're adding on to 102.5. So we need to put those together, and that comes out to 145 feet. So every time we add a car, we don't just add 40, we also have to add a 2.5. So we are adding 42.5 every single time we add a car. Now, as we talk about that, that's huge for letter C now, where we go to create the equation that represents this. So we had the 60, we added one car, we added 42.5 to that. We added another car, we added 42.5, not just the 40, but 42.5. Every single time you add a car, you're adding 42.5 feet. So which equation says that? We're starting with the engine, which is 60, and then we're not just adding 40. So A would be if you just added 40 and there was no space. It's going to be letter C, and I want to write it out so we can see it. 60 plus 42.5 C. So for every car, you're adding 42.5 to the 60. These over here are saying that you're starting with 62.5 and then adding 40 every single time. Well, if you went and added, let's say, two cars, you've got that 2.5 in there once, but every single car there's another 2.5. So this doesn't work out, and there's another reason it doesn't work. But if we look at letter D, okay, so we started with 62.5, and then every car we're adding another 42.5. That almost sounds correct. The problem is we're not starting with 62.5, we're just starting with 60, because if you plugged in 0 for 0 cars, so you take all these cars off, how long is the train? It's not 62.5. There's not that extra 2.5 space when you're measuring how long just the engine is. Just the engine is 60, and then every time we add a car, it's 42.5. Okay, letter D, we're going to graph the equation that we found from 1 to 5. So we're going to quickly make a graph, and we're going to go from 1, 2, 3, 4, and 5. And we also have 0 here. So we know 0 is going to be at 60, and then we're going up by 42.5 every single time. So we need to leave some room. I'm going to count by 60s. If you wanted to, you could even count by 50s or 100. In fact, let's do that. That's even easier. 50, 100, 150. You get to choose. 200, 250, 300, 350, 400. We'll see if we even get there. So at 0, I know my train is at 60 feet long. Now we should label our graph. This here represents the number of cars, and this here represents the length. And so we already calculated for 1, it's at 102.5, so just above the 100. And for 2, it's at 145, so just below the 150. And so what we need to do then is for 3 is just add another 42.5. So we're at 145, we're going to add 42.5. So we're at 187.5, so just under the 200, plus another 42.5, it's 230. So right about here, and you should see this is a nice straight line, plus 42.5 is at 272, so right below that 300 line. And you should see this is straight. It's linear. It forms a line. These types of equations form straight lines, and we'll talk much more about that as we go on here. Now, we don't want to connect this. A lot of times it's every student's first reaction is let's draw a line and connect it. The reason is the domain here is not going to include all our real numbers. It's just a 1, a 2, a 3, or 4. You're not going to add 2.6 cars and want to know how long is it. You can only add 1 car or 2 car or 3 cars or 4, not in between. So we don't connect this. By connecting it, you're saying there is values between the dots, and there's not. Okay, and then letter E. So letter D was to draw the graph. Letter E, find the length of 12 cars. So you could continue adding all the way till you get to 12, but the whole point of the equation here is that it's usable. And so the length, which is T in this case, the length of the train, and they tell you that up here, let T be the total length, equals 60 plus 42.5 times C, which is the number of cars. So they're asking you for how much for 12 cars. So because we have this equation, we can plug directly in. So we're going to do 42.5 times 12. Every car adds 42.5. So for 12 cars, that adds 510 feet. But we also have the engine, so we need to make sure we add in that 60. And that comes out to a total length of 570 feet. Okay, we're doing 3 through 6. So a lot of these graphs and charts. So let's go on to number 4. So our tree trunk has a 12 centimeter radius. So the distance from the center of the trunk, that's a radius, center to the outside is 12 centimeters. So that means the diameter all the way across is 24. So we're talking about halfway across. But regardless, we're starting with 12, even if you don't fully understand what it's talking about. It's starting with 12, and the radius increases, so we're adding 0.5 per year. And they actually give you the equation right here, y equals 12, your starting point, plus 0.5 for your number of years. So for 1 year, you're just adding 0.5. For 2 years, you would do 2 times 0.5 and add that to the 12, on and on and on. So first thing they want us to do is make a quick table here. And so we're going to have our x and our y. So when x is 0, your starting point, y is 12. So for year 0, when you start, the radius of this trunk is 12. After 1 year, they're telling you it increases by 0.5. So 12 goes to 12.5. 2 years goes up another 0.5, so that's 13. Another 0.5, that's 13.5. Another 0.5, 14. And it doesn't specifically tell you how far to go, so I'm only going to go to 5. Now draw a graph. So part B. So again, just going to sketch a quick graph here, counting your x values on the bottom. So 0, 1, 2, 3, 4, 5. We'll just graph the ones that we've got here. Now what does x represent? X is your years, so let's make sure we label that on our graph. And then our y is the radius, and that's in centimeters. And we want to pick a good number here. If we counted by like hundreds, that wouldn't make sense because all our numbers are between 12 and 15. So we need to make sure that that's visual here for us. So if I go, let's say by 5s, 5, 10, 15. Well, here's 10, here's 15. All of those are going to be between there. So depending on how spread out you want this, you can count by different numbers. Let's see. I think that's actually decent. Let's go 5, 10, 15, 20. And at 0, we're at 12. Now, I do want to harp on this for a second. There's no right or wrong way to pick the numbers you're going to count by, but we don't want all of our numbers to be jammed in like a little section over here, and then the rest of our graph is empty. So we try and spread out the data on the graph as best as possible, and so we choose numbers to try and make this graph look visually appealing, but it's not like there's a right and a wrong way to do it. So at 0, we're at 12. After 1 year, we're at 12.5. Hasn't moved much. 2 years, we're at 13. 3 years, we're at 13.5. Now, this isn't perfect, right? But we're doing our best. It's just a sketch. 4 is at 14. 5 would be at 14.5. And if we actually got to year 6, we should be at the 15, going up 0.5 more. So that's good enough on a graph. It's not perfect, right? We're not using graph paper. This isn't a perfectly straight line, even though it's supposed to be. and that's fine. It's just a sketch. And letter C. After how many years will the radius equal 20? So we're starting with 12. It's 0.5 every single year. Let's pretend for a second it was going up by 1 every single year. Not 0.5, 1. So we'd be at 12. How long to get to 20? That'd be 8 years. And so since it's going up by 0.5, half of 1, it's going to take twice as long. So instead of 8 years to go from 12 to 20, it's going to take twice as long because it's only going up by 0.5. And so that's going to be 16 years. Now, I just reasoned through it. You could also use this formula here. And we haven't quite gone into all of this yet. But if I wanted to go ahead and plug in for y, they want to know when is y 20? When is the radius 20? So change y to 20. And what you do is you solve this equation. We haven't fully gone into that, but here's what it would look like. You would minus 12 from both sides. We're trying to solve for x. So we wanted to say x equals. So we minus 12 from both sides. I end up with 8, and I still have a 0.5x. And to solve this, this says 0.5 times x. To undo it in an equation, we're going to divide by 0.5. When you do 8 divided by 0.5, you're going to get the 16. So kind of more of a quick preview of where we're going with this and what's going to be expected down the road. But you also have enough information to just reason through this and figure out 16. If you need to just keep this table going to get to the 16 years, that's fine too. However you need to get there. But eventually, we want to be able to use this equation. Makes our life much, much easier as we try and solve this. All right, we are on to number 5. So we're going to draw the graph of y equals 4x. Now, we've kind of done all positive graphs where we just went like this and then had our positive numbers going up. And if you started like that to do this, it would make sense because that's all we've done. But eventually, we are going to talk about y equals negative 4x, and we're going to have lots of negative values. So for this one, they really didn't give you a clue that you should do this, but you're going to want to make what's called the 4-quadrant graph, where you have all of your positives and negatives represented. So we're going to have 0, 1, 2, 3, 4, and we're going to have negative 1, negative 2, negative 3, negative 4. Let's put these, and we'll talk about what we want to label those. So the first thing you may want to do is make a quick chart. If you're like, how do I even start putting this on the graph? So we're going to do y equals 4x. That's the equation we're trying to put on the graph, y equals 4x. So just plug numbers in for x, find out the y, and then you can plot those. So if I plug in 0 for x, 4 times 0 is 0, so y equals 0. What if I plug in 1? 4 times 1 is 4. What if I plug in 2? 4 times 2 is 8. So if I was plotting that, I've got 0, 0. Let's call this, since this is already going up by 4s, we're going to go 4, 8, 12. So for when x equals 1, I'm at 4. And when x equals 2, I'm at 8. When x equals 3, 4 times 3 is 12. I'm here. And if I wanted to go into the negatives, what happens when it's negative 1? If I plug in negative 1, 4 times negative 1 is negative 4. So when x is negative 1, it's negative 4. And you can see this line is going to keep going down here. So at 2, it's going to be negative 8. And at negative 2. At negative 3, it's going to be negative 12. And this is our line here. Now this line does have values because it's not designated to something specific. It does have values between those dots. We're not talking about some context where we can only count by whole numbers, so we can connect those lines. And then on part B, so that was A. Part B, they want you to now graph y equals negative 4x. So I'm going to quickly make a chart and do the same thing. So at 0, if I'm plugging into y equals negative 4x, 0 goes in. Negative 4 times 0 is 0. What if I put 1 in? 1 times negative 4 is negative 4. 2 times negative 4 is negative 8. What if I put in negative 1 though? Negative 4 times negative 1, that's positive 4. Put in negative 2. Negative 2 times negative 4 is positive 8. Okay, so let's put these on the graph. We have 0, 0. So both of them are going to be right there. But then when I go to 1, it's it's negative 4. So that's down here. When I go to 2, it's negative 8. If I go to negative 1 on my x, it's positive 4. If I go to negative 2, it's positive 8. So you can see this line, if I connect these dots, it's going this way. So let's label them. This is y equals 4x. This is y equals negative 4x. So I've done letter B. Letter C, at which 2 points do they at which point do they intersect? So they only intersect in one point. It's right there. How do we identify that? What's the x and the y value? And it is 0, 0. That's the point that they intersect, 0, 0. And then letter D, describe any patterns that you observe. So you come up in your own words what this looks like. You could say, well, they form an X at 0, 0, something like that. But what's actually happening is they're actually just the reflection. So if you take everything on the right side here and you flip it over to the other side, so if I took this line and I just flipped it over, it would become this line, and that's called a reflection. And reflections are over lines. We're flipping it over a line. The line we're flipping it over here is the y-axis. So this is a reflection over the y-axis. And that's not something I expected you to know, but I want you to see it. If I took either one of these lines and I just flip them over this axis, just flip them over, you actually end up with the other one. Okay, so that's called a reflection. It's a preview to what's coming. So I didn't expect you to know this and be able to answer this question on your own, but I wanted you to see it and hear it now that that's a reflection. Okay, number 6. Flooded stream is now 30 centimeters above normal level, and the water is dropping at a rate of 3 centimeters per hour. X is going to be the number of hours. Y is the level above normal. So let's say we wanted to write an equation. We're starting with 30. We're minusing 3 for every hour, and x is the hours. And so you could say y equals 30 minus 3x. This equation, you can plug in any number you want for x, which is the number of hours, will tell you the water level. So suppose the water level continues to drop at the same rate, write an equation. Well, I actually already just did that, jumping ahead. So y, the height, equals starting point of 30 minus 3 times every hour. So letter B, we're going to graph it. So again, what I suggest is you make a quick XY chart to help you graph it. This is not the graph, this is a table, but this helps you graph it. So we're going to count by hours on the bottom, 1, 2, 3, 4, 5. And we want to know what's the height. And we'll talk about how much we want to label these as in a second. So when x is 0, x is your hours, and y is your height. So when x is 0, if you plugged it into the equation, 3 times 0 is 0, so you're just left with 30. And that should make sense for the situation, not just the equation. 0 hours is your starting point. The stream is 30 centimeters above. So when it's 0, it's 30. And then after 1 hour, we know it's going to drop by 3, so 27. So after 2, it's going to be 24. After 3, 21. After 4, 18. So it keeps dropping by 3. So if we counted by, say, 5s, 5, 10, 15, 20, 25, we could get up to 30. So if we wanted to do it that way, it's fine. Or you could go 10, 20, 30, which is what I'm going to do. And we don't even need to get up to 40 because we're starting here. So at 0, we're at 30. And by 1, we're at 27. And by 2, we're at 24. And at 3, we're at 21, just above the 20 line. By 4, we're underneath the 20 line at 18, and it would continue to drop and drop and drop and drop. Now notice that I connected it. Does that make sense? So this is your hours. Is the stream, so this is the height or the depth of the stream, is it going to have a height at 1.5 hours, or is it only going to have a height at 1 hour, 2 hour, 3 hour? So clearly, there's time between the full hours, and that river is going to have a different height, or the stream is going to have a different height between those hours at 1.5 hours or 2.6 hours. It is going to have a height, and it's going to be between these two numbers. So connecting this makes sense. So before you just quickly draw a line, you need to make sure it makes sense for the situation. So it does. And then letter C, use your graph to estimate when the stream is expected to drop to a level of 6 centimeters above normal. So we would have to continue this on to see that. So let's continue it on. So 6, 7, 8, 9. So we're continuing to drop by 3. We're at 18. So 15, and then 12, and then 9, and then 6. And so on your graph, this point right here represents 6 centimeters. And so the answer here for letter C, estimate when the stream is expected to drop to a level of 6, that is in 8 hours. All right, we did 1 through 6, or we did 1 and then 3 through 6. And now we're doing 11 through 14, just some quick review now. We're getting away from our graphs. Looking at some reciprocals and some properties of 0 to do some quick mental math. So number 11, you look at this, you see fractions. A lot of people just shut down and say, oh my gosh, I don't want to do all that. So we want to look closely in how am I going to do this in my head. If you look inside parentheses, if you look at the two fractions that you've got, they're flipped. The 9's on the bottom, the 11 goes to the top. This h is written on the side, which means it's also up top. And so it's on the bottom there. So these are reciprocals, meaning when you multiply them together, you get 1. Because on the top, we're going to get 99. On the bottom, we're going to get 99. We're going to have an h on the top. We're going to have an h on the bottom. So we're going to have a 99h on top. We're going to have a 99h on the bottom. So anything divided by itself is just 1. So since I see that these are flipped versions or reciprocals, I know when I multiply these together, I just get 1. So all of this mess that looks complicated is just 1. And it's 1 times this. And 1 times anything is just that number. So it's just going to remain 9/11 h. And so that's how come you can do all of that crazy looking math in your head. How about number 12? We got this big number, 95,620. We're multiplying it by 657. You say, I can't do that in my head. Me neither. But if you look at the whole problem, you're minusing that same number being multiplied by 656, which is just 1 less. So remember that multiplication is just repeated addition. So you're actually adding 95,620 657 times. So plus, 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 plus. Obviously, we're not going to do that. And then here you're doing it 656 times. So let's pretend for a second this was the same number, 657 both times, or 656 both times. You'd end up subtracting this by itself. This number times 657 minus this number times 657, we'd get 0, right? But we're not doing it the same amount of time. We're doing it 1 less time. So it's just 1 less 95,620. So we're going to take this big number and subtract this one, which is just 95,620 less, leaving you 95,620. 13, multiplying all these big numbers, not something you have to do in your head. I noticed that there is a 0 in this, so it doesn't matter. Whatever I get when I multiply all these big numbers and decimals, in the end, I am multiplying by 0, and anything multiplied by 0 is 0. 14. At first glance, these look like reciprocals, right? So I should get 1, and when I multiply times this, I'm just going to get 9.85. So the problem is I have 13s here, so in a way those cancel. But then I have 4 and 40. So those don't quite cancel. But I want you to think about 4 over 40. If I simplified 4 over 40, dividing by 4, divide this by 4, divide this by 4. Just in my head, 4 divided by 4 is 1. 40 divided by 4 is 10. So the 13s cancel. 4 over 40 basically is 1 over 10. And so I'm left with the 9.85 on top, and I'm left with a 10 on the bottom, basically. You can write it out however you want with the 1/10 over here and the 1. But basically, I'm left with this on top, and I'm left with 10 on the bottom when things simplify. And so what I'm actually doing is this divided by 10, and you should be able to do that in your head. Let's talk about what happens when you divide by 10 or you multiply by 10. Decimals just move. So if I had 9.85 times 10, you notice, look, it's still 9, 8, and 5. What happened? The decimal moved one spot to the right. So when you divide 9.85 divided by 10, it actually just moves one spot to the left. So I'm showing you on the calculator, but that's eventually something you can just do in your head. You just know dividing by 10 or multiplying by 10 moves this decimal left and right. So dividing by 10 makes it smaller. It moves it one to the left. And so my final answer is 0.98.